Hi, everybody. Hope you're doing well. So, we are going to spend some time talking more in depth about camera fundamentals today in our second series, Camera Fundamentals 2. Okay, and so we're going to talk a little bit about stops, equivalent exposure, how to use your manual mode, and a few other important camera settings. So, just a little review. What are three things that determine exposure? We know that the ISO setting or the sensor sensitivity setting factors in the intensity of light entering the camera or the aperture, how big that opening on the lens is to let in light to the sensor, and the time of the exposure um, when you make the picture. Okay, and we call that the shutter speed. So we can think of those three primary factors that influence exposure when we take a picture. And we can think about them in terms of being kind of a triad or a triangle, each equivalent or equal in their ability to affect the exposure that you get. So let's talk a little bit more about each of these. So ISO is a measurement unit that tells us how sensitive the sensor is to light entering the camera. And every time the number of the ISO doubles, the sensor's sensitivity to light doubles. So when we go from, say, ISO 400 to ISO 800, we have just doubled the sensitivity of the camera to light. So let's think about what that means. What should we set that ISO to? The lower the ISO, the better image clarity you're going to have and the less sensor noise, but you're going to have longer exposure times. The higher ISO you set, the more flexible shooting you're going to be able to have for hand holding or fast moving subjects. But that higher ISO also is going to decrease the apparent resolution and color accuracy of your image. So you can see a little bit of that here on the right. Let's take even a closer look. So here's a slice of the same composition or scene, but it's shot at various ISOs, starting at 200. Then we see one at 1,000, at 1,600, ISO 3,200, and even 6,400. But you can see one of the things happens is that noise becomes more apparent in the image when we're zoomed in up close. This also is going to affect color accuracy, although it's a little more subtle. The more noise you have, it's not only luminance noise, but it's also color noise. And although we have a lot of good software that can help correct for this, it is something that factors in. And here again is another comparison of as we go ISO 100, 200, 400, 800, and 1600, it's not so important these actual values because sometimes as cameras manufacturers are getting better at making cameras sensitive to light, this changes over time. But what's important is that we see sort of this degradation and loss of information. So the blues here, especially when you see how clear that color blue is, it's almost like a sky blue or baby blue. But then as you get into the 1600, you really see not only is the image noisier, but the accuracy of that color has shifted. It's not the same hue exactly. So another thing besides ISO, of course, is aperture. And this is a good picture that just reminds you again, what we're really talking about is how much light is able to go through the lens. There's a diaphragm on the lens and it's going to change. So if you have a low f-stop number like f2, you have a big opening letting in a lot of light through your lens. But on the other end of the scale, say f16 or f22, we have really closed that down and you have a very small opening. That's going to have an effect, of course, on the way the image looks, but it also is controlling the exposure for you, how much light's coming in. The third component of our triad is shutter speed. And shutter speed is not only going to affect how long or short your exposure is, but it's also going to affect the way things appear in your image based on how, if it's moving or not. So if you have a very short shutter speed, such as like a 7/50th of a second, it could stop something pretty effectively that's in motion. Whereas if you have a longer shutter speed, say a 30th of a second, then you are going to see blur if there's something moving across your frame. So all three things affect exposure, and the choices you make on which of those three areas, ISO, shutter speed, or aperture, that you're going to focus on will determine kind of the outcome and look of your photograph. Great. So now what we want to do is talk a little bit more about stops. So how do we measure exposure? That's really the question. We know the triad, ISO, aperture, shutter speed, all three of those affect how much light comes into the camera, and thus it affects the exposure. But how do we actually measure it? How does it get kind of settled up so that we result in a good image? Well, we use something called stops in photography. Okay, a stop. Not very descriptive. What does that mean exactly? So, one, a stop is a way of measuring exposure. And a stop is always it always represents the same amount of light. Two is a one-stop increase in exposure means the amount of light reaching the camera sensor has doubled. So if you think of it in a math equation, if you have an x, now we're talking 2x. We've multiplied it by 2. Let's take a look at that. So here I've got a scene of a bridge. It's shot at 1/2000th of a second at f7.1. And this is kind of the normal that the camera said would be a good exposure. And overall, it's looking all right. Now, here we have the same picture, but instead of shooting it at 1/2000th of a second, it's been shot at 1/1000th of a second at the same aperture. And that has increased our exposure by one stop because I've effectively doubled the exposure time. And you can see it's brighter than the original. And just to think about how that math works, remember 1/2000th of a second plus 1/2000th of a second would equal 2/2000ths of a second. And if we reduce that down, then that's 1/1000th of a second. So you can see 1/1000th of a second is equal to 2/2000ths of a second exposures. And thus it's doubled. And then if we go one step further here, now we have a picture that's 1/500th of a second, again at the same f-stop. And so that's 2 stops brighter than the original. And you can really see we're starting to feel a lot of overexposure here by overexposing by 2 full stops. Now, number 3, a one-stop decrease in exposure consequentially means a halving of light reaching the camera sensor. So if we think about it as an equation in math, if we had a given amount of exposure called X, now we giving you one stop less of light into the camera, now we're going to have reduced that down to half the amount of light. So it's a half of an X. So again, let's take a look at that. Here we've got a scene, it's shot at 1/800th of a second at f8. As the camera meter indicated, and we've got a good general exposure. And then here we have one stop less light entering the camera. We've adjusted the aperture this time from f8 to f11. So our aperture opening got a little bit smaller, and we're letting in half as much light. And so you can see that the trees especially are looking darker than before. And if we look at the math again, we've gone from f8 to f11. And so we've reduced our light down by half. Now I'm going to show you one more where we shoot it at f16, and that will be Again, having the amount of light coming in to make the exposure again. So it's going to be quite dark, as you can see. And we've really reduced by, I'm sorry, this says +2 stops, but it should be -2 stops. And we've reduced that amount of light by 2 stops, and thus it's really just a quarter of the amount of the original light that we were looking at.